Welcome back to our video series, Everything About Public Schools. My name is Blaine Helwig. Today's focus, teaching decimal magnitudes by viewing a decimal of any size by thinking money. Glad you're with us. The video's main focus is on decimal magnitudes, a key aspect of decimal numeracy for students in 4th grade through 6th grade. However, this video may be helpful to middle and high school teachers tutoring academically struggling students. There is a free downloadable PDF packet with all the exercise referenced in this video located at the website the new3rseducationconsulting.com under the video tab. Or you can just Google my name, Blaine Helwig, and follow the links. Let's get started. Decimal numbers can appear huge to elementary and middle school students, even when they are not. Take the following decimal, 1.238069. To a kid, this decimal number looks big, as if this amount of money is a winner's take in the Powerball Lotto. However, once they develop the numeracy skills to better understand decimal numbers and their magnitudes, these type of decimal numbers are as easy to comprehend as is their understanding of whole numbers. Let's look at the pedagogy of decimal number magnitudes and simplify this process for students. Let's prove how small decimal mechanics can vastly improve students' mathematical numeracy and understanding. We need an easy demonstration exercise that visually shows students the value of each digit to the right of the decimal point. I recommend that teachers get a little crazy here with a decimal example that emphasizes physical meaning. So let's choose 15.834167. The teacher can show students how small a digit's value becomes by moving one digit at a time to the right of the decimal point. Let's rewrite our decimal. Then use the 1 under the decimal point process to compute an equivalent mixed number to our decimal. This process was outlined in the video, Decimal Fraction Equivalency, and it can be viewed at the website, the new3rseducationconsulting.com under the video tab. Let's continue. Replace a 1 directly under the decimal point. Now we add zeros, one at a time, and show that the value of each digit to the right of the decimal point decreases rapidly as we move to the right. We'll examine the fractional value and the place value of each digit to the right of the decimal point. Let's add our first zero, the tenths place. The value of the 8 is 8/10. This fraction is significant since 8 out of 10 boxes are shaded. Let's add another zero. The hundredths place value. The value of the 3 is 3/100ths, smaller, but still a significant fraction. Add another zero. And we're in the thousandths place value. Only 4 boxes are shaded out of 1,000 total boxes. 4 thousandths, a small proper fraction. Add another zero. And we're in the 10,000ths place value. And the value of the 1 is 1/10,000ths. Only 1 box is shaded out of a total of 10,000, smaller yet. Actually, this fraction is about the diameter of a human hair. Let's continue by adding another zero, the 100,000ths place value. And the 6 has a value of 600,000ths. Only 6 boxes are shaded out of 100,000, a very, very small fraction. And last, let's add the last zero in the millions place value. And the value of the 7 in this decimal number is 7 millionths. In fractional terms, only 7 boxes are shaded out of 1,000,000 equal boxes. An exceedingly small fraction indeed. Let's add a couple commas and a horizontal line to simulate a fraction, and our decimal's overall size is 15 and 834,167 millionths. But the approximate material size of the decimal can be found in money terms, $15.83 or 15 83/100ths. So what's the takeaway? The takeaway is that only the first 2 digits after the decimal point materially influence the decimal's overall size. The remaining digits to the right of the first 2 digits, the tenths and the hundredths place, are so small in value that they are not able to significantly affect the decimal's overall magnitude. This fact allows both students and adults alike to view a decimal of any size and immediately know how big it is. In the next 3 slides, let's go over 3 examples that provide students a better understanding of the size of the decimal numbers when they view them. Moreover, this numeracy process is essential for students in grades 4 through 6. It's a 3-step pedagogy. First, think money. Second, circle the decimal that includes the hundredths digit. Third, draw a quick number line to provide students a visual understanding of the process. Let's work the first example, 13.042. First, think money. We are only interested in the money value of the decimal. Second, circle the money value of the decimal to the hundreds place value. Third, draw a quick number line so students possess a visual understanding of the mathematics. Label the salient numbers, usually the bookend whole numbers and the midpoint will be sufficient. Add our decimal on the number line since we know it's about 13.04. Discuss distances from the whole numbers 13 and 14 and the midpoint 13 and 1/2. Our decimal is about 4 1/100ths from 13 and 46 hundredths from 13 and 1/2 and 96 hundredths from 14. The counting up to make 10 video provides students a numeracy ability to easily count up to desired quarter or half points or to either of the two whole numbers. It is also available at the new 3Rs educationconsulting.com website. Let's work another example. Remember, it's a three-step pedagogy. First, think money. Second, circle the decimal. Third, draw a quick number line. Let's look at the second example, 0.4609. First, think money. Again, we are only interested in the money value of the decimal. Second, circle the money value of the decimal to the hundreds place value. Third, draw a quick number line. Label the salient numbers, usually the bookend whole numbers, and the midpoint will be sufficient. Add our decimal on the number line since we know it's about 0.46. Discuss distances from the whole numbers and the midpoint. Our decimal is 46 hundredths from 0, 4 hundredths from 1/2, and 54 hundredths from 1. Finally, deepen students' mathematics understanding by adding in the quarter and three-quarter points into our decimal numeracy. Example 3, 3.471. We think money. We know only the first two digits, the tenths and the hundreds, really matter on approximate size. Therefore, we know that this decimal is about $3.47. We know it's 3 47 hundredths or 3.47. As before, draw a simple number line on a small dry erase board, on a piece of notebook paper, or physically on their desk with dry erase markers. Label and plot your decimal, in this case 3.471. Let's draw our number line. We know that 3.471 is between two whole numbers, 3 and 4. Halfway between 3 and 4 is 3 1/2. And then equidistance between 3 and 3.5 is 3.25. Similarly, halfway between 3.5 and 4 is 3.75. We know our decimal is about 3.47, so we can bring that in and plot it. Now, we can ask the following decimal questions. About how far is the decimal 3.471 from 3? It's clear from the number line, it's about 47 hundredths. How about from 4? About 53 hundredths. From 3 1/2, 3 hundredths. From 3.25, 22 hundredths. From 3.75, around 28 hundredths. With sufficient practice, students become very adept and numerate at this process. A quick recap of the video. 4 main points and 1 recommendation. Point 1. Place a 1 directly underneath the decimal point and add zeros under each digit to the right of the decimal point. This allows students to A. Understand place value of each digit to the right of the decimal point, the tenths, the hundreds, the thousands, etc. And B. That only the first two digits to the right of the decimal point influence the decimal number's overall size. Point 2. The video concentrated on a 3-step pedagogy to find the relative magnitude of decimals. By first, think money. Second, circle the first two digits to the right of the decimal point. And 3, make a number line plot to provide students a visual. Point 3. On that number line plot, add in the quarter points, 1/4, 1/2, and 3/4. Then discuss with your students the distances from those points to the two bookend whole numbers. Point 4. Our goal, that when students are shown a decimal, they view that decimal mentally based on its magnitude. Example, 21.4712901. How big is this? Well, it's about $21.47 or 21 47 hundredths. Between what two whole numbers is this decimal? Between 21 and 22. Distances away from those whole numbers? From 21, it's about 47 hundredths, and from 22, it's about 53 hundredths. Final recommendation, Teachers, always provide your students threshold repetitions so they may master the content. Thank you for watching. I hope this short video was helpful in your work in the public schools. Please check out our other videos and resources.